Hello and welcome to another video. In this video we're going to be working on find the prefix common array of two arrays. And in this one you're given two arrays of length n, and a prefix array is an array of length c, such that for every element that's equal in the two arrays you have an extra element there. So essentially if you say like I want to compare all elements up to some index, you're going to compare these and you're going to say how many of these are equal. And so return the prefix common array of a and b for every single index, and n is a permutation if it contains all the integers 1 to n, and this is guaranteed. So so let's look through these. So essentially this is up to index 0 prefix, so that would be like this, and there's 0 equal elements. Here this is index 1, 2 equal elements, 3 equal elements. So the order doesn't matter. You can basically just like imagine you take all the elements, you turn them into a set, and you compare for equality, something like that. And then the last one is they're all equal, so 4. And then second example, there is nothing here. There is 1 here, just the 3. And then at the end, they're always all going to be equal because it's the same elements. So yeah, basically, how do you do this? And the constraints, to be honest, are like really easy. So this is closer to an easy problem because you can just have like an n squared that'll easily pass. But how do you do it, I guess? Well, actually, yeah, I mean, basically we can just have like an n squared solution. So essentially we can just traverse both arrays and then like put elements into a set and just compare for equality or something like that, or an array or whatever. But we can have also an O1 space solution. I think that the more efficient way in terms of big O is you can say like when elements are equal, maybe take them out of both and just add 1 to like the permanent equality, something like that. But it doesn't matter because worst case scenario, like things are going to be equal at the very end, so the big O runtime will be the same. But essentially we can just go through both arrays, and yeah, we can basically just go through both arrays, keep adding things to a set and compare for equality. And by compare for equality, I mean we have to check like how many elements are in both. So you can do a set union in Python, or set intersection, I think, and that will give you an answer. So essentially, like if I have a set of like 1, 2, 3, 1, 2, 3, and then I have another set that's like 2, 3, 4. If I do a set intersection in Python, this will give me the set of 2, 3. And so you can basically do that and just keep getting set intersection, and then that will give you your answer. You can also do this in O1 space because this is only up to 50. So essentially what we can do is we can just maintain, for A, we can maintain a number, and for B, we can maintain a number. And the number will just maintain, like, is that number in here? So you can use bit manipulation for that. So basically we're going to have a number that just starts off as 0. Yeah. And then, like, let's say we wanted to turn on the number 3. We can just take, the way you do this to turn on a bit in a number is you just take a 1, you shift it left this number times, and then you turn, and then you OR it with your number. So 1 shifted left 3 times will basically have a 1 in this position. So 1 starts off here, shifted left 3 times will be a 1 here. So this will be this number here. And then you can just do a bitwise OR. So bitwise OR will just put a 1 here. And then you do the same thing for the second number. So let's say your second number is whatever, some other number, like let's say this is currently your second number, something like that. And let's pretend all the empty spaces are zeros. And then you can just AND both of these. So when you AND both of these, you'll get 0. But let's say they did have some bits that were turned on for both of them, meaning the numbers in both. So let's say we had this here, there's a 1 here, you know, something like this. Okay. So like what would this do? So this would give us the result of 1, 1, and then the rest of it would be 0. And then the resulting number, we can just count the bits. So to count the bits of a number is also an easy problem. We can just keep taking the last bit, check if it's a 1. If it's a 1, we'll add to the result, and we'll keep doing that until it's 0. So essentially, let's go through example 1 with that kind of way of doing things. So let's get rid of all these. Just do this, actually. Okay, so let's get this. And I don't need these. Copy. Alright, and then let's actually make a third array. Yeah. Okay. So essentially what's going to happen here is, and we can even label this as like the indices. So this will be like index 0, 1, 2, 3, 4. Okay, so we're going to go through the first digit of the number, and we're going to say there's a 1 at the, let's say this is A, this is B, and then this is the like the combined. So the first digit of number is 1, so we're going to take a 1, shift it left once, and AND it with A, so we're going to get this. First digit here is 3, so we'll have a 1 here. Then we'll AND these together and we'll get 0, so this has no shared bits, so that will just be 0. Then for the second number, so the first thing of the result will just be 0 here. Then for the second number, A is 3, B is 1. So now when you AND these together, you'll get this. This has two 1 bits, so then the result here will be 2. Then for the third number, A has 2, B has 2. And this together, you get 3 1 bits, so there will be 3 here. And then finally for the last one, you'll get these, and so you'll get this, and then this will be 4. So that's essentially what you can do to have an over 1 space solution. You can use bits. But honestly, if this goes up to 50, you can use an array as well. Just compare arrays, compare sets, whatever you want. Basically anything passes here, so this is like a pretty easy problem. So we'll use bits just to make it more interesting. So let's define a function that will give us the bits in a number. Like I said, it's pretty simple. Call it bit count, and it's just going to take like a number and return a number. And this works because this is up to 50, so like an int in Go is 64 bits, the default int. So if this was any bigger, then we wouldn't be able to do that, but 64 bits will fit 50 numbers. So we can just say result 0, and then while or for A is not equal 0, give me the last bit, and it with a 1. If it's a 1, add 1, and just shift the number. And just keep doing this, just return results. So that's basic bit count of a number. Now we're going to have a result here, and we're going to go through these two arrays. So for 0, okay, and then we need two numbers to maintain of like what are actually our bits of A and B. So we'll just do this, make them 0. So in order to take the current bit and add it in, we can just say this. We just take a 1, shift it by A at the current index. Same for B. Then we'll get C, which is just A and B. It'll give us the bits that are in common, and then we can add the bit count of C. Okay, and we can return. Oh, right, so this actually needs to be an array, so we can make an array instead. So instead of adding, we can do an append. All right. Oh, and this needs to be the other way to go. Okay. All right. Okay, so yeah, so instead of using the bit, you can also use an array of 50. It doesn't really matter. You can basically say that's, I guess you can say it's length A space, but this is the one space. So yeah, but I mean the thing is for this bit thing, yeah, if this gets any bigger, then you can't use this. You have to use the array. So it's kind of like for a small number you can use an array, but it doesn't really matter. For a big number, you have to use an array or set or something. You can't use bits. Maybe in Python you can actually. I think Python your number can be as big as you want, so you can use bits. But I don't know how big numbers are made in Python. Maybe like a combination of numbers, so it'll probably take less space. But yeah. So this is n and 1. And yeah, it's gonna be all for this one. Pretty easy one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.